Good morning, everybody. Open any newspaper or website and you're bombarded with headlines about this huge dearth of analytics talent in companies today. As companies try to move into adapting towards data-driven cultures, all this noise is enough to make one believe that we are on the brink of a disaster. But is that really the case? Is there really a huge skill gap? And if there is, where does it lie? In today's talk, I'd like to address this and a few other questions, such as what are the key roles in organizations that require niche competencies? Does this talent exist? And how do we find them? Also, we'll talk about how to upskill existing talent and also what are the key things to keep in mind when we're talking about training effectiveness. The sexiest job of the 21st century is also perhaps one of the most abused terms of the 21st century. Now, if you think about it, whenever we hear about the shortage of analytics talent, the most common assumption is that we lack data scientists. The underlying expectation is that the data scientist is responsible for anything and everything related to data, and that every problem could be solved if you just hired a data scientist or two. So in most companies, there is a search for this almost mythical creature who has mastery over every imaginable talent, and he would be able to unlock the data conundrum. So let us first try and break this myth. For this, let us look at the data science machine learning life cycle, and I'd like to refer to a heat map that will help me talk about the different stages in this life cycle and also the skills required for each of these stages. So at the very source or at the very beginning is business. There is tons of data coming out of business, and the goal is to be able to analyze all this data and derive some intelligence which would help in arriving at some outputs or outcomes that might help business. So all this data is collected and stored in some way. It is then ingested into maybe a platform or a tool, and then it needs to be prepared. Now at this stage where data is being collected, ingested, prepared, there is a need for specialists, big data administrator and a big data developer. So the big data administrator's role is to be able to create these large clusters so that they can process and manage big data. It is their responsibility to handle all database administration related activities. The second role is that of the big data developer, and you might have heard many different terms in this context. Hadoop engineer, data engineer, Hadoop architect, lead developer, and so on. Now all of these refer to the same role more or less. Now this role is responsible for the actual coding or programming of Hadoop applications. And one of the trends that people are predicting is that data preparation, which accounts for over 50% of data science work, will soon be automated. So this means that this will free up the specialists' time for other tasks. So moving on to the next stage, once data has been prepared, it is now ready to be explored, and this is where the data scientists or big data analysts, as they are sometimes also referred to, play the main role. So the data scientists are responsible for processing all this data. They are looking at statistical analysis, they do feature engineering, they decide upon what kind of algorithms and models to build. And at this stage, there is another important contributor who is the domain expert. There is a need for domain experts because very often data scientists are lacking in industry experience, and they're lacking in an understanding of the business. So the domain experts are the people who have complete business acumen, they have strategic thinking, they are able to arrive at insights, and their inputs are very critical at this stage. So moving on, once the data scientists with inputs from the domain experts have decided upon what models to build, they go ahead and develop it, and then they test it rigorously. At this stage, there is a need for another specialist, the data visualization specialist. So as data grows more and more complex, it is important to be able to distill it and to bring it to life through visualization. So it is important that we are able to effectively communicate highly technical information in non-technical format that is understandable for most business executives, and managers, which is why we need data visualization specialists. So once the model is built, it is ready for production, and then it is delivered back into the business, where it will hopefully achieve the goal of improving the original process or the outcome that the business had. So as you can see, there are many different stages in this life cycle, and there are many different roles involved in each of the different stages. Now let us quickly look at the skills required for each of these roles. You have the big data administrator who handles huge volumes of heterogeneous data, so they need to be skilled in Hadoop. They need to have a knowledge of Linux operating system. They need to have general operational expertise, troubleshooting expertise, and so on. A big data developer translates complex functional and technical requirements into detailed design. And they should have expertise in Hadoop and Hadoop ecosystem. They should have good backend programming skills and hands-on experience in MapReduce, Hive, Flume, Oozie, etc. The data scientist needs to have extensive experience in programming and extensive statistics background. They need to be able to very confidently handle analytics tools like SAS or Python, and they should be well versed in advanced techniques like multinomial regression, as well as text mining and natural language processing. A subset of this is the machine learning specialist, and they need to have expertise in techniques like neural networks, random forest, support vector machines. So as data overwhelms organizations, advanced techniques like these, which generate insight with very little human interference, are becoming indispensable. The data visualization specialist needs to be skilled in Excel or Tableau so that they are able to come out with vivid visualizations. They're able to come up with intelligent, comprehensible reports and very precise dashboards. And then, of course, we have the domain expert who needs to have deep organizational knowledge, industry or functional expertise. They need not necessarily have any statistical or programming skills, just business acumen, executive skills, and strategic thinking. So as you can see, different skills, different roles, definitely not one mythical creature. Now let's step outside this data science life cycle that we were looking at so far and look at the organization as a whole. At a very tactical level, you have the role of a business analyst. Now the business analyst is someone who combines analytics knowledge with domain expertise. Now these people are very valuable to businesses because they look at the role of analytics in the context of a business problem or an opportunity. They need to have a general understanding of basic statistical concepts and a high-level understanding of popular algorithms. They might not have very deep technical knowledge, but they do have enough analytics ability to be able to drive analysis on their own. This brings me to another set of people who are often overlooked when it comes to building analytics capability, the business and the functional specialists. So I'm talking about the brand managers, the product owners, the operations specialists, the supply chain people, and also marketing specialists and so on. Now these people need to be trained in the use of analytical tools and techniques so that they can query data and analyze results. So for example, a brand manager in an FMCG company should have enough analytical capability to be able to take smart decisions based on data. So they should be able to analyze sales data from their retail outlets to understand how pricing or seasonal promotions could impact sales. There are many business and functional analysts who are reaching out to us individually to upskill themselves because they feel that these skills will definitely help them do their jobs better. So there is a huge opportunity here, and companies must consider upskilling many of their functional and business specialists. So what we have seen is that skill gaps exist in two kind of areas. You have the data science roles and you have the analytics enabled roles. NASSCOM too has identified many similar kind of roles in the big data analytics domain that need to be focused on in the upcoming years. So now that we've seen where these gaps exist, let's talk about how we can fill them. Hiring from colleges and industry is one option, and upskilling your existing talent through training is the other. So let us first talk about hiring and college programs in particular. For the entry-level technical kind of roles, hiring from colleges is always an option. However, at the undergraduate level, there are no degree programs which offer specializations in these areas. So for example, if you're looking to hire a data engineer, BTech engineering or a BSc computer science program might cover the programming skills, but they might not have hands-on experience in specific tools and technologies. At the postgraduate level, many colleges are now beginning to offer analytics as an elective. But again, these are very broad-based, it's a very broad-based subject and not a very deep specialization. The one course that has generated quite a bit of interest recently is the PGDBA program, postgraduate diploma in business analytics, that is offered by jointly by IIT Kharagpur, ISI Kolkata and IIM Calcutta. This is a 2-year full-time program, and students spend about 6 months in each of these 3 institutes focusing on different areas of business analytics. So at IIT Kharagpur, they focus on the technical aspects of analytics. At ISI Kolkata, they focus on the statistical and machine learning theories in analytics, and IIM Kolkata focuses on the application of analytics in the functional areas of business. So it seems to be quite a comprehensive program, but the first batch is just coming out this year and one needs to wait and see how it will pan out. The other type of programs that are very popular among working professionals are the executive programs that are typically offered by Tier 1 colleges like IIM and ISB, and also Tier 2 colleges. These are typically short-term 1-year programs, and again quite broad-based and a little theoretical in nature, which is why many of them often bring in guest faculty, SMEs from the industry who can bridge this gap in domain knowledge and in the practical applications. Another niche program in this area is the PGPDM program, postgraduate program in data science and machine learning, that is offered by University of Chicago Graham School and Jigsaw Academy in collaboration with IBM. And it caters to the need for skills in high-end machine learning, deep learning, and artificial intelligence. And finally, we have the certification programs. Now, these are very popular among working professionals who want to specialize in very specific areas. These are typically offered by specialist training institutes. So for example, a database professional wanting to move into a big data developer kind of a role might consider a big data specialization course from one of these institutes. And the advantage with these institutes is that they offer short-term programs as well as long-term programs depending on what they are interested in. So they could specialize in a single tool or technology, or they could look at a broader, larger specialization as well. So these are all your options when it comes to hiring from colleges and institutes. Hiring from the industry at a lateral level is another option as well. However, the challenge there is that very often it's very hard to find people with the right mix of skills and experience that one is looking for. So the other way to solve this problem is through upskilling of existing people in the organization. And this brings me to the last part of my talk here today, training. As a part of a corporate training offerings at Jigsaw Academy, we have trained hundreds of professionals both in classroom as well as in via an online training platform. And I'd like to share a few key learnings from our experience. We always recommend that companies look at answering a few of these questions as a first thing, as a first step before they even start any kind of training program. How will my trained employees practice their newly learned data skills? What kind of data problems are present in our organizations that can immediately be put to employees as potential problems for them to resolve? Do we have access to the analytics and big data tools that they have been trained on to further practice and hone their skills? How can the application of analytics and big data be made more relevant to their current job profiles? These and a few other similar kind of questions are what we feel companies should ask before they start any training program. Now, these are a little tough questions in the sense that there are no easy or quick answers. However, training will be effective only if the individual's goals are aligned with the training objectives, it will be effective only if the organization is supportive of the newly learned skills and if the learners have the opportunity and the resources to be able to practice and to apply their newly learned skills. When it comes to training programs, one size does not fit all. So firstly, different people are at different starting points. So say for example, you nominate people from the IT team and the business team for a data scientist program. Now people from the IT team might not have any knowledge of statistics but might be very well versed with programming. People from the business team on the other hand might have great domain knowledge, maybe decent statistics knowledge, and will be completely unfamiliar with programming. Now putting all these people together into one single training program, a standard training program, is not likely to yield results. At the end of the day, they all need to be learning all of these areas, but since they are at different starting points, one standard program would not work. So just as different people are at different starting points, not everybody has the same end goal. So a functional manager, for example, needs to be trained in the basic use of tools and techniques, but they do not necessarily need to be specialized in advanced machine learning techniques or very complex analytical methods. So one good idea is to have 3 levels of training programs, basic, intermediate, and advanced. And the participation in these programs should typically follow a pyramid structure. So everybody should go through the basic program, a subset of that should go through the intermediate program, and then only a select few based on their knowledge, their aptitude and the role and their interest should be allowed to go through the advanced program. So this brings me to a related topic, just-in-time training. Learning should be continuous, and it is important to ensure that a certain base level of knowledge and skills have been taught, but specific tools and advanced techniques should be taught only as and when required. Application is key. Learners should be exposed to the right mix of the real life case studies. So on the one hand, participants should be made to practice problem areas, problem statements that they are likely to face in their roles in the organization. But at the same time, these case studies should also not be so specific that they learn only to solve those specific problems. So it is important to have the right mix of case studies. The other point I'd like to make here is with regard to assessments. So it is necessary to test for conceptual knowledge. So you have to know if people have understood their concepts well. It's also important to test for the ability to be able to apply these concepts, especially when you realize that these solutions could be arrived at through different tools or through different technologies. So a good way to go about this would be to ensure that your assessment covers maybe a capstone project in simulated environments. Many analytics training programs have very unreasonable expectations both from learners as well as from the trainers. For example, you cannot put 30 novices into one training room for 1 week and expect 30 data scientists to emerge at the end of the period. That incidentally is a true story. So an ideal way to teach analytics would be to expose the students to one concept, to one topic, and then give them the time to assimilate this, preferably through case studies, through hands-on learning, before you move on to the next topic. So this means that the training program should involve learning inside the classroom as well as outside the classroom. And when you're looking for training partners, look for someone who can deliver it both within and outside the classroom. So for within the classroom, this means that they should have a great faculty. Look for people with strong academic credentials and industry experience. And for outside the classroom, look for great content and a robust platform that can help deliver this content effectively. So while evaluating training platforms, look for 3 things. Look for scale. Can the platform handle large volumes? Can it deliver a uniform training experience across the board for global teams, for distributed teams? Secondly, look for format. What is the content format that is available on this platform? Do they have videos? Do they have transcripts? Do they have MCQs, capstone projects, case studies? What is the content that is there? Thirdly, look for insights. So look for a platform that can give you deep, in-depth analytics on how the program is progressing. So it could be metrics like who's on track, who's falling behind milestones, who's ready for the next level, and so on. Now, since learners are learning outside the classroom when it comes to the platform, it is important that you have complete knowledge about what's happening. So that when you have this insight, you're able to take action as and when required. So I'd just like to conclude by saying that the skill gap in analytics talent does exist, only not as we originally thought of it. There is a demand not just for data scientists. There are data science roles which involve other kinds of people. It involves people like data visualization specialists, domain experts, and so on. There are also analytics enabled roles which involve people like business specialists, functional specialists, and decision makers. Now, all of these people and all of these roles require analytics capability. And the skill gap will only widen if we do not take systematic steps to address this. So as companies trying to adapt to a new data-driven culture, here are 3 things you can do. First, understand the current skill levels of people across business, both in data science roles as well as in analytics enabled roles. Second, look for new outputs and outcomes that you expect to see once you implement analytics, and also identify the key roles involved in this implementation. And third, look for identifying the specific skills or identifying the additional skills that might be required for these new roles, and then think about how you want to fill these gaps, either through new hires in case the gap is wide, or through upskilling of your existing talent in case the gap is small. Finally, I'd like to end by asking a very simple question. How many data smart people does your company need? And the simple answer to that is everybody. Thank you. Yep.
Talk about various profiles that are lifecycle. Can you give us some idea in terms of the distribution of the service company or probably a brand? Like what percentage of people would be domain experts or so?
I think it is a range, so it depends on, it also depends on how much of analytics is being implemented in different kinds of companies. So for example, in your IT companies, obviously the distribution is very different. Also in several setups, for example, in a marketing kind of roles nowadays, we are increasingly seeing that there is a huge chunk of people who are in roles that are analytics enabled. So it differs from company to company and depends on how much, how far along the life cycle they are currently. We are definitely seeing a lot of current companies, people are coming out to us, reaching out to us saying that they want to be upskilled in a lot of different areas. And I think far more than people moving into data science roles, we are looking at people in functional roles who are saying that they want to be trained in these areas. So we are seeing a lot of demand for HR analytics course or for marketing analytics, finance analytics, and so on. So that's the kind of interest that is currently being seen.
And in terms of the size of the organizations, like the startups, somebody may be playing multiple roles on this same front, right? And as it grows,
absolutely.
they might be taking up.
So typically in smaller companies, you would see that many of these roles merge, and you would see that the distinction between the different roles do not necessarily exist. Obviously, in the larger organizations, it is much more evident. Very often, I mean, that's one of the reasons probably that many people think that a data scientist should know everything, and typically they do understand the various stages of, and they're able to engage with the various stages of the life cycle. But resources willing, size willing, the idea should be that they should focus on specific tasks where different roles have different tasks. So, yeah.
Like I see a lot of overlap between the data engineers and the data administrators, and specifically in the startup and a new vertical in an organization, it's very difficult to have kind of two people doing very similar job. In terms of talent, is it available? How available is that?
Absolutely. There are people who are currently manning multiple roles, and especially in smaller organizations, smaller setups, startups and so on, you do find that people are scaling across different roles. You'll find that in some companies you might not even have somebody called as a domain expert. You might just have some, the data scientist himself would have kind of acquired all that knowledge. So, which is why I think there is a large case to be made for upskilling people. So very often we are finding in smaller organizations, people are finding that they have to do other roles which they might not have already been trained for, and their kind of role is kind of expanding into wider areas. So very often some of the courses that are available in the markets are also very broad based. So they try to cover different areas so that people coming into the jobs are better versed and are better equipped to handle these kind of challenges.
Your view on the future, the people who have these bucket skills, the people who will survive for the market. What's your personal view?
I think there's made for both. One should have a broader knowledge. So for example, a data scientist would need to know, information related to how data is being collected, prepared, and so on. They also need to know business kind of roles. But at the same time, as technologies emerge, they would also have to be super specialized in the kind of things that they are doing. So, they would have to get more into machine learning and neural networks and so on. So, there is a case for both.
Hi, there's a question here. Of course, you all get a chance to work with a lot of different corporates. What are some of the best practices when it comes to measuring the effectiveness of trainings that you deliver, analytics trainings?
Okay. So the effectiveness is, so there are many ways to look at it. So one is that we do look at what kind of return on investment has happened. So for example, if you were to say compare the cost of a new hire to the cost of training a person, what is the return on investment that you have looked at? The other thing that companies often talk about is the project readiness, or is the person job ready. So the training program is considered effective if a person has gone through it, has handled enough case studies, has handled enough problem statements, and is able to get on to managing these kind of roles within their organization. So very often what happens is there's a lot of conceptual knowledge and not enough of practical application, not enough of practices done. So the job readiness or market readiness or project readiness is one key metric that a lot of companies do talk about. When it comes to online programs, the other thing that companies talk about is program completion itself. See, because in a classroom training, you do have people sitting in and going through the course, so you assume that the knowledge is gained. But some amount of training and learning also happens outside of the classroom, and that is where it is important to track whether people have actually learned, whether they have actually gone through the entire course. And in some ways, platforms do help in being able to measure whether they have completed the program as prescribed. So those are the various points that typically companies reach out to us for. Yeah. Okay, thank you very much. Thank you for your time.